Hello, good evening all. Yes. Yeah, it's nice to see all of you are smiling, very happy in the class. Yes, very good. So, yes, Jim, Harris, Elena. Yeah. So, what we are going to learn today, it will be graphing rational functions, right? Especially in the rational function, we will graph vertical asymptotes. We already completed what are asymptotes and what are their types. So, today only we focus on the vertical asymptotes only, right? So, when we say it's a rational function, okay, so quickly recall, okay, can you just pick which of these three functions are rational and which are not? Yes, you can reply with the color, whether it is orange, green or blue. So which are rational and which are not? Yes, Jim. Oh, very good. Yes, nice, Elena, nice. Yeah, so okay, so all of you are saying that this function in this green, yes, it is a polynomial. Very good, very good. So let's see what is a rational function? Function which is written in the form of px over qx, right? Means a polynomial in the numerator and another polynomial in the denominator. Here are three examples. Each one of these are rational because yes, in the numerator a polynomial and there is a polynomial in the denominator. Yes. Okay, very good. So now coming to vertical asymptote. Okay. Yes. So what's a vertical asymptote? It will be a vertical line, of course, yeah, which meets the curve at somewhere around infinity, right? So if it's a vertical line, what will be its equation? Yeah, it can be typed in the chat also. Yes, x is equal to constant, right? So let that constant be 8, right? So this is 8, h. Okay, so what will be h? Yes, h will be value of the function that makes value of the x that makes value of this function infinity, right? That means it makes the denominator alone to 0, right? So if this denominator is 0, okay, then this will be asymptote, but it should not be x minus 1 because it is in the numerator also, right? So what we have to do first, we have to factorize this polynomial, right? Because we need linear factors, right? So how can we split this minus 3x? Yes, minus 1 and minus 2. So minus x and minus 2x. And this function is written factored as x minus 1 over x minus 2 into x minus 1, right? Okay. So x minus 1 is a factor in numerator and denominator. It won't be considered as an asymptote, right? So what will be the equation of asymptote? It will be x minus 2. Yes. Now you can think upon what is this common factor x minus 1, which is common in numerator and denominator. It is making 0 to both numerator and denominator. We will discuss that in some later class, right? So you keep on thinking about it, right? Okay. So before moving on, so what will be your first step in finding out vertical asymptote? You need to factorize all the polynomial in numerator and denominator and try to identify that factor which makes denominator alone 0, right? Okay. So before moving ahead, let's have some fun, right? So we can have a quiz. Yes, there is a link for Nearpod in the chat. What you can do, copy it and open the Nearpod. Yes, you see that question. What is the question? There are given the 4 functions and 4 equations, actually 3 equations of vertical lines, right? You have to match the function with its asymptote, right? Yes, you have only 2 minutes for that, right? Oh, yes. This is blank because one of these function does not have a vertical asymptote. So you have to identify that function and pair it with this blank one, right? Okay. Yep. So 2 minutes completed. Right. Let's see what are the pairs. Yes. So this is -2, -2. So can it be factored? No. Yes. Good, Harris. So this cannot be factored. That means this will paired with this, right? And here, what is denominator? Minus 7x and plus 2x. So minus 4 into minus 3. So where is 4? Here is 4. So this function will be paired with this. Good, Jim. Very good. Yes, here x square minus 36. So it will be minus 6 and plus 6. So this will pair with it. And the remaining one, let's cross check it. Minus 3 and 2. So minus x and minus 2x. So it will be x is equal to 2. Yes. Okay. So Elena, why you have two problems? Okay, you paired this with the wrong one. Okay. So when you make one mistake, it will automatically you will get another one also incorrect, right? Because you will not have three correct in this. Yes, very good. So okay, so now you can find the equation of asymptote, vertical asymptote algebraically. Now, yes. Now again, open Desmos in your system, yes, and try to graph this function. Yes, enter that function f of x is equal to x minus 1 over x square minus 3x plus 2. Yes. Yes, you can reply in chat whether it is number 1, number 2 or number 3 as per your graph. Which graph matches with your graph? Yes. Okay, Harris, it's number 2. Okay, let's see. Jim, number 2, very good. You are Elena, number 2. Yes, all of you are saying number 2. Let's see what's the answer. Yes, it's graph number 2. Yes. No, don't close that graph. You have to do something more. Now again on this graph, try to draw the asymptote of that function. Yes, just put a vertical line x is equal to a, make a slider for a, yes, and move that slider, yes, so that the line moves to position of the asymptote. And then, yes, and then you have to read the value of it. Yes, naturally. Right? Let's see. Yes, so this green line is vertical asymptote, right? So when you move the slider, value of a in the slider, this line will move in this direction to left and right? And you have to stop when this line comes in this position. Very good. Yes, it's simple. No? Yeah. So now, what we learned today? Yes, what we understand asymptotes and their type. This is not today. We already did this in the previous class. Yeah, we can find out equations of the vertical asymptote. We can find out. Yeah, we can graph them on graph of the functions. Yes. So, any doubt? Any one of you? Do you have any doubt? No? Okay.